So today we are going to solve LeetCode question, group anagrams. So what does the question say? We will be given an array of strings or vector of strings, and we have to return a 2D array which will be grouped together like this with the logic. They have specified that suppose we have a string eat, then this string contains an E, an A, and a T. We have to find another string in this array which contains these specific characters, and it is not necessary that they should be in order, like to eat. Let us take T also contains these three characters, A, T. Okay, so these two will make a pair, and we will store them in a 2D vector. Eat, T. Now, are there any other pairs which follow this logic? Let us see what about rat. Now, rat contains three characters R, A, and T. And art. If you look at art, again we have these same characters used. So this will also make a pair. Not pair, like there can be more than two. So this will also make a group. Alright. And then let's check about these two. NAT. Right. There is no other string in this vector which contains NAT. Okay, so this is alone a group, like NAT. And same for bat. There are no other uh, strings in this vector which contain these three, BAT. Okay, so this was the question. Now, how can we approach it? Let's see. Now, we can use maps to solve this question, but how? Uh, if we try to come up with an idea, what we can do is let us take all the strings, okay? And how can we check that what characters does this string contains? Like, it contains only three characters, EAT. Okay, rat contains only three characters, RAT, and same for others. But how can we check or how can we differentiate that which string contains which specific character so that we can map them? So what can we do? What we can do is we can create a either we can create a vector of 26 size, okay, and initialize it with 0. So what is the fundamental logic behind this 26 size vector? We know that in our A to Z alphabets, we have 26 characters. And in the question, it is specified that all the characters are going to be lowercase. Okay. So we can create a vector. We can name it anything. Suppose we name it M. And we give it a size of 26. This size 26 uh, specify, no, denotes, not denotes. Or we can say we can relate these 26 indexes with A, B, C, D, all these characters till Z. Like if we take 0 as A, our 1 will be B, 2 will be C. This is not actually happening, we are just assuming. Okay, so suppose we made a 26 size array and we are assuming that 0 index is A, and accordingly 1 will be B, 2 will be C. And initially we are initializing all these with 0. Okay. And what does this 0 signify? That for this string, for this specific string EAT, currently currently we have not iterated in EAT. So at the beginning, there is no yes, we can say that these zeros are considered as frequency of how many times every character has appeared in this string. So currently, when we have not iterated in this in any specific string, we know that all the frequency of all characters A, B, C till Z are 0. And when we will start iterating, like when we will apply a for loop on this string, we will end up increasing the frequency. Okay, when we reach to E, what we'll do is we'll go to index of E. Suppose 1, 2, 3, 4, yeah. Fourth index will be mapped to E in our mind. So initially there would be a 0 stored here, but as we see that we got a E in our string, we will update this count to 1. This signifies that in our string E has appeared a single time. Then we'll go to A, we'll update the index of A. Then we'll go to T, we'll update the, suppose it is here, update the index of T to 1. Now this vector which we have created, NP, this will look something like 1, 0, 0, something like this. And it will be of fixed size 26. Now we can use this vector as a key in our map. Okay. Now the idea behind the idea behind this approach is that now we have got a unique set of unique vector which represents EAT, or which represent that uh, in this string we have these three characters stored. And what we can do is go to every other string and check if this what do we say, vector matches the frequency count of this. Like if we'll try to create the same vector for rat, okay, then what will happen? The index containing R, A, and T will be 1, and remaining indexes will be 0. So we can see that map of RAT is different, map of EAT will be different, but if we compare the map of EAT to map of TEA, they would be same. Why? Because of the simple reason that EAT contains three characters, A, E, and T, and TEA also contains those three characters. So it is obvious that their vector, their MP vector would look identical. Okay, so that is the main logic behind creating this MP vector. Okay, so I have created that MP array, which will be used as a key in our map for every single string. Now you can easily be able to visualize what I'm trying to say. Let's see. For it, this will be the map. Okay. Now, is there any other map which looks exactly similar to this? Let's check. R, no, there is a difference. So not rat. Let's compare it with the ART. Again, there is a difference. Now compare it with T. This is same, this is same, and this is same. So we have found a match. Okay. Now continue the search. If there are any other more any more other variation possible. So let us compare it with NAT. So there is a difference. Here index of M will be something else. So we can't, these two are not same. And let's compare EET with BAT. So we can also see that these two are not identical. So For eat, we have found T as a match. So when we will find a match, what we will do is in our map, let us see how our map will be written. We'll make a map, unsorted map, unordered map, vector of int. Okay. And then what we will do, we will store the indices or indexes of these matches that we have found. So what will be the index of EAT? According to this, 0. So we'll store 0. And what about T? 3. We'll make another vector, another array or vector int, which will store these indexes. Okay, so that we can later use them, create our answer. Now let us continue with our algorithm. Our algorithm, next step will be checking for rat. Okay. Now if we look at RAT, are there any other identical arrays will match, which will be matching with this? So you can see ART is a total match. So we can make a pair and we can see that no other string is matching. So we'll store indexes of these two also. Okay. So what is the index of rat? 1. What about our art? 2. Okay. So currently, how is our map looking? Let us visualize it. When we stored eat initially, okay, we can't visualize this whole map. So let us make a block. This is a block for just to visualize this array. Okay. And what about what is being stored in its value? Indexes, an array of indexes. So it will look something like 0, comma 3. Okay. This is one entry. Next about rat. These two will be different. Okay. And for these, we found two indexes, 1, comma 2. Let's go further. We have already got T, so no need to check that. What about NAT? You can see that there is no match for NAT, so only one index will be stored, its own index. Is its index 4? And lastly, BAT. BAT also has no match, so it will store its own index, which will be 5. So finally, we have got a map which is storing indexes of the string which are going to be grouped together. Okay, so you can write a simple loop to group these together. It is not a very big task. Okay, so indexes 1, comma 2.
अच्छा टैकल किया जनरली
Then we can add indexes 0,
बल्ले के
3
बीचों
in
बीच
this way,
गेंद लगी और दूसरे
and
छोर
4
से शुभमन गिल जिस तरह से खेल रहे
and
हैं
5.
वो
So this
काफ़ी
was
अच्छा
the
लगता है क्योंकि
basic
उनका
approach
जो
behind how
प्रेजेंस है
to
और कॉन्फिडेंस लेवल
solve
का
this
है
question
या
using
बॉडी लैंग्वेज का है
maps. Okay,
वो साफ तौर से नज़र आती है
but there is a slight issue with this. Not suppose, but a single element. We can't use a complex data structure like vector or array as our key. Okay, in case of unordered map, we can use a normal map, but that will increase our time complexity to log in. So it is not preferable. So we can't use vector as our key, and we don't want to use a normal map to store our map. So what can we do? There is a solution to this problem. Instead of creating a map to store the locations of uh, characters which are occurring in a string, we can use a string instead. Okay, so what we can do is replace this vector int, which was of size 26 and initialized with 0, with a string, again name it anything, of size 26. Okay, so logic will remain the same. The vector was storing whichever character that was occurring in your string. In the same way, this 26 size string is going to store the same thing, obviously, but in form of characters. Okay, like everything. Let us suppose we are initializing all the indexes of the string with 0, 0, 0, 0, 0, 0. Okay, so whenever we come across a character, what we can do is go and replace this 0 with 1. Okay, or then 2, and so on. So yeah, that's the final algorithm or whatever to solve this question. Let's look at the code once. So here is the code. First of all, what we have done is created a map. Okay, an ordered map, and we have took string, as we discussed that we can't use an vector as a key in our unordered map. So we have used a string and then a vector of int to store whatever the indexes of those matching pairs or matching groups would be. Okay, named it anagram groups. Next, these are two for loops. Let's see what is the use of this outer for loop. Okay, this for loop is iterating through the whole array. Okay, the array which we have been provided with. Yeah, this is the strs which we are given. So one by one we are accessing each of this string. Okay, see, and now what we have done is created a dummy string key of size 26 and initialized it with 0. Okay, now what we are doing, construct the key based on letter frequency. Now the map of the vector which we were talking about, which was going to store the frequency of all the characters which occurred in that specific string. Yeah, that logic is written here. What we are doing is that for every character in the string which we have selected. Okay, like when we are in this loop, when I will be equal to 0, we will be standing on eat. Now in this eat, we are going to iterate one by one on e, then a, then t, and what are we going to do? We are going to increase the frequency of e, a, and t in this string. Okay, and these, yeah, and then what we will do, we are going to push back. Where? Why we have used pushback? As you can see, uh, we are using a map and we are accessing the value of map, or the second part of the map. Okay, so why we have written pushback? We have done this because for every key, every unique string that we are creating, we want to push the index. We talked about that, no? What we were doing was that for every unique, uh, how do we say this? What do you say? Every unique vector. What we were storing? We were storing the indexes of these similar maps, okay, or vectors. So it is nothing but that. Okay, we are accessing the key, then simply pushing back where, in this array. This array is going to store indexes of all the strings, which is similar to this EAT, TEA, etc. Okay, so this storing logic is still here. Now we have to extract the answer. Okay, as we can see, we have to return a 2D array. Okay. So how are we going to do that? Firstly, we will create a vector of string, that is a 2D array, or we can solve a 2D yeah string, nothing else. Then what we'll do is apply a for loop on the map. Okay. So we are accessing every entry, or here I have written entry, but you could have used I, J, K, anything you want. Okay. So I'm accessing every element in that map. And what am I doing? This is a dummy string created named group. Okay. So for you to understand this, we have to first go back and check what was stored in our map. Okay. So in this map, we can see our key was this string. Okay. And our value was a vector containing the indexes of the answer we have to push back, or answer we have to give back. Okay. So key is a string and value is a vector. Now let's go back to the code. Yes. Now what we are doing is we are accessing the value using dot second function. Okay. And we are iterating in it. Why? Because we have to make a group of those words using their index. Okay. So we are accessing those index, and then we are going to make a array out of them, array of string out of them, or vector of string out of them, and then that string will be pushed back to the final result. Okay, so let me show you actually what is happening. This might be a little bit confusing. So what this line of code is doing, that we are going to, like, this was our map. Okay, let us suppose this is our map. This is map dot first. Okay, it is a string. We do not need to worry about this. And this is map dot second. Okay, and this is a vector of int. And what is it storing? It is storing indexes of all those string which are having same what do we do, character stored in them. So suppose for some specific map, there are 0 and 1 stored here. And what we have to return, and according to what we have to return, what we have to do is create a vector. Okay, dummy vector. So let's create a vector of string, name it something like group, suppose group. Okay, we will add the strings which were stored at this index. Okay, and how will we do that? For we will how will we access it? For int I, and here we will write map dot second, and we'll simply push back group dot push back. Now where are these stored? These are stored in the main strs which we were provided. Okay, and we'll simply pass I, because not I, wait, no, fine, it is I, because we have to simply get the string which are stored on this index. What this will do is it will create an array named group, which will have whatever it was there was in zeroth index, what was there on first index. And now finally we will add this vector of string to the 2D vector which we have to return. Okay, so earlier we had created a vector of string. It was named, let's see, it was named result. So we'll simply do result dot push back, and we will pass the group in it. So let us suppose this was the result 2D vector. We simply push back our group in it. Okay, EAT. Similarly, this will happen for all those maps, and finally we will get our answer and we can simply return it.